Good evening to all, and thank you for allowing me to present the paper me and my colleagues have worked on titled Medical Drug Analysis Using Graph Neural Network. These will be the table of contents that I will be covering in our presentation today. Now, moving on to the introduction part. One drug can interact with the biological pathway in various ways and cause a rippling effect in the biological network. The atoms can interact with each other in various ways. While this can be studied, various exceptions always arise. This is where deep learning can be applied, from fully connected neural networks to graph neural networks. These high performing models have been helping scientists automate this task. Uh, Moving to the related works. Ever since their inception, GNNs have been playing a key role in NLP, drug analysis, and computer vision. Various models, such as graph attention networks, graph sample, and aggregated embeddings, etc., have shown exceptional accuracy. Have shown exceptional accuracy in drug development and drug analysis. From their foundational work to the current state of art models, GNNs have shown their ability in drug analysis and discovery. Moving on to our proposed methodology. For the dataset, we have used SCEECS'21 dataset, which was developed in collaboration with the NIH, EPA, and the FDA to come up with the better and cheaper ways to develop drugs. These molecules are industrial chemicals, pesticide, food additives, and drugs which have been screened to find their properties. As for pre-processing is one of the most important steps as it ensures a smooth training process for both the models. For FCN, the data is normalized to a data range of -1 to 1 to ensure high stability of the model while training it. As for GCN, the SMILES, that is, Simplified Molecular Input Line Entry System code for each molecule has been taken from the dataset and converted into graphs. Moving on to the models. As we can see in the figure B, it represents the FCN the FCN model that we will be utilizing. The initial input layer is designed to accommodate a feature vector of 799. This is necessary since it allows the network to capture a myriad of molecular properties and potential interactions. The fully connected block consists of neurons followed by a dropout layer of 0.5 and a leaky ReLU activation function of 0.1 negative slopes. The feature vector is expanded to 1024 and then undergoes an intended contraction, decreasing the neuron count by a factor of 2. Moving on to the GCN model which has been developed. The block of GCN used is made up of series of operations, a graph convolutional layer, batch normalization, and rectified linear unit function. We have also introduced a residual link of graph convolution and batch normalization to combat the problem of oversmoothing in graph. Despite popular graph methods like graph sage and graph attention networks, we use GCN due to its simplicity and straightforward nature. It offers seamless integration of node features from nearby nodes, which makes it easier for the model to understand the molecular structure. Uh, okay. As we can see in our table 1, we can see that the accuracy that the GCN has beaten the fully connected neural network in all the parameters from loss to accuracy. Moving on to the results and discussion. GCNs are more than capable of detecting different parts of a molecule and relating the properties of atom to each other. This has been used by this property is very essential since the atoms are interacting with each other, which helps the model in understanding the potential interactions between the molecule and the biological pathways. And from the graphs, we have illustrated that the GCN has beaten the FCN in the 8 datasets that we have taken from the TOX21 dataset. Moving on to the conclusion. Despite high computations and characteristics of the molecule being fed into the FCN for training, it fails to provide the desired information. GCN was also found to be more computationally efficient than the FCN. Since the entire molecule is analyzed by the GCN, they prove to be more efficient for analyzing medicine. It can also help to automate the process of drug analysis and generation. Here are our references. Thank you.
Okay, Chaitanya, only one question. Good presentation, very good.
Thank you,
The
sir.
question is like I see in the FCN, na, is it fully
100%.
connected network? So why you see that this table, the performance is decreasing over these data sets. Maybe you are getting 8, but in case of GCN, you are achieving better. Any observation?
So the observation is just that because the graph convolutional network, is taking in the entire molecule as an input, right? So the thing is, they are, and we let me try to explain it in a better way. In our preprocessing step, right, we have been converting them to a graph, and each of the atom is being given a one hot encoded vector which has its properties, and along with that the bonds have also been given a one hot encoded vector which will also include its properties. Now when the GCN will take in the data, the input, it will use the convolutional method and combine the information and give out the output.
Okay, fine. Thank you, Anna. Thank you. Good.
Thank you, sir.